Let's trace CritterDemo1, a program that's available on Mr. Minick's Java homepage to help understand how critters operate in grid world. Here we have a little client program with a main method. We're declaring and instantiating a world. Don't worry about that. You don't have to do anything like that on the AP exam. Then we're adding in a bunch of rocks and flowers, and look at this. We have two critters. Again, you won't have to write client code on the AP exam, but you should know how to trace it. So let's look at this closely. At the location 44, there's a critter right here, and notice that this top row is row 0. So he's really on the 5th row down, and he's in the 5th column to the right. So that's the location 44, and there's another critter here. There's also a crab critter at location 39. We'll maybe have time to discuss that in this video later. And then the all-important world.show line of code, which just makes this graphical user interface pop up when we run the program. Okay, again, that's not really our concern there, the client program. Let's now trace how a critter acts. When you click the step button in the GUI, that causes each actor to act. And it works in a first come, first row order. In other words, this flower gets a chance to act, and then this flower, and then this rock, and then moving over here to this crab critter, and finally the critter that we're focusing on gets a chance to act. Since rocks don't move, we know that that rock will still be there when it's this critter's turn to move. And flowers don't move either, so that critter won't be going anywhere either way. So what happens when I click this step and this critter does an act, calls his act method? Well, here's the act method that we need to learn how to trace. First, this if statement. This is just checking to make sure that this grid exists. It actually is checking to see if this critter has a grid. Well, that critter does have a grid because he was placed into the location 44 of world, which was instantiated here and declared. So everything's square and up on the up and up as far as the grid goes. Rarely, if ever, on the AP exam do you have to worry about this if statement being false. I've never seen it happen. So let's just skip over that. Okay, this is a line of code. We're declaring a local variable named actors. Its data type is an array list of actor, and it gets whatever the method getActors returns. Well, since there's nothing in front of this, there's nothing like Bob dot notation. This assumes that the getActors method is somewhere in this current class. Let's shrink up all these methods just so we can see them easily in this video. I like to do this every once in a while to see the big picture. Here in Eclipse, it can be confusing otherwise with lots of code. Hey, here's the method getActors. So we are tracing that method. Or we just assume that whatever its post condition states, that it actually happens. So this method returns a list of actors that are neighbors of this critter. Well, the neighbors of this critter are the things that are in the surrounding 8 squares, locations. That rock and that flower are its neighbors. So an array list of size 2 is returned by that method and plugs in for this local variable called actors. If you don't trust that getActors does what it says it's doing, then trace the code. That's one line of code, that's all. It's making use of the grids. This grid is what is returned when this critter calls his getGrid method. So this grid calls the getNeighbors method, which is considered black box. Deep in your quick reference, somewhere in this quick reference, is explained the getNeighbors method. And you can just assume that it works because it just does. And it returns it's provided the location for 4, and it just works. So I now can assume that the local variable actors has a size of 2 and probably found in the 0 position of that array list is this rock, and probably found in the 1 position is this flower. Next, we call the method processActors, which takes that local variable actors as a parameter. Now, I guess you really didn't need that variable. Instead of even using that whole line of code, they could have just typed getActors, empty parentheses there, because that's quite fine. We don't need to waste memory and store that return value in a variable. And really, behind the scenes, it doesn't waste any memory. It's just, it comes out the same in the end when it executes. So don't be misled by somebody who does this as one line of code and somebody else who uses 2 lines of code, as the College Board authors of this of this critter class did it their way. Well, anyway, what does processActors do? Let's find it first. The processActors method is right here, and it apparently eats the actors around it. So this array list of size 2 gets passed in to processActors. And processActors is just a nice way of saying eats, because look at this code. Using a fancy for each loop with this colon instead of a regular traditional for loop, each actor that's in this array list, in other words, the rock and the flower, they each plug in for A, and because the rock is indeed a rock, and the not of a true is a false, and when you have a false ANDed with something, the overall Boolean is false. So rock does not remove itself from grid. In other words, critters do not eat rocks. And they do not eat critters, other critters also. Now apparently they do eat bugs. And apparently they do eat flowers and other things that you might find being placed as neighbors around a critter on the AP exam. But for now, we just realized that processActors causes this rock to not be eaten, but this flower will be eaten. When I click the step button, eventually, you will see the flower go away, but the rock will not. Okay, what happens next when a critter acts? Well, in addition to eating the edible things around him or her, we have this variable moveLocs that is an array list of locations, not to be confused with an array list of actors that we were just dealing with. And that variable is set equal to whatever is returned by the method getMoveLocations. Let's go take a look at that method. Here it is, and that method gets the possible locations for the next move. Blah, 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 blah. Well, let's trace the code and see if we could figure it out without having this nice description. Get the grid again, and then get empty adjacent locations. So I'm just going to assume that the empty locations that are around the critter after he has processed and eaten the edible things around him, those are all possible move locations. So how many move locations would that be? In this particular case, 7. All 8 of these locations that surround him, except for the rock, because the flower is already gone at this time. Unless these 2 lines of code right here were switched in a different order, he has 7 possible move locations rather than 6, which would be a wrong answer on a tricky AP question. Well, now that we have that set of possible move locations returned back up to the act method and stored for our convenience in a variable called moveLocs, we pass that variable, moveLocs, that array list of size 7, we're passing it to this method, Select move location. What the heck does that do? Oh, right here it is. Select move location picks one of those available adjacent empty locations for the next move. And it does so randomly. I bet they're using the random method when I drop this down. And they are. They are generating a random integer. Notice how they have to typecast here, because random is a decimal number until you do that. And they're storing it in this variable r. And they're using the get method to pull the location out of the array list of locations that was passed here. So we are picking one location out of the 7 locations that we had to pick from. And this code, of course, could probably be written shorter. It certainly could be written with better style, with curly braces and blank lines and all that. But hey, it is what it is, and they're saving paper at least when they print this code on your test packet on the AP exam. And so that's that. So let's just pretend that one of those locations was randomly picked, and now we're back up here, and that location was just now stored in this variable called loc, which is a location because it's a row and a column tied together. It's not an int, it's a location object. Another one of the black box classes that you have to be familiar with in the quick reference guide on the day of the AP exam. These are the exciting ones here: bug, box bug, critter, chameleon critter. But there are ones like location, and there are ones like rock and flower and grid that, well, you don't have to know as well, but you should still know them if you want to get a 5 on the AP exam. Okay, we're almost finished then. We have that location, and now we send it as a parameter to the MakeMove method, which happens to be right here. All these methods that we just made use of were right here in the critter class. Some of these methods actually called other methods that were in unrelated classes, but we pretty much glossed over that in this video. Finally, we look at this MakeMove method, and it calls the move_to method to actually make the move. Now, where's the move_to method, I'm wondering? It's not typed out here in this critter class. Well, if a method, first of all, I'm trusting that it works. I'm trusting that it just moves the critter to this new location. But I'm curious. I want to know where it is. Well, because there's no variable named Bob or whatever dot in front of it, I assume that it's this object. It's the implicit parameter here, this, which really just refers to the critter himself. More specifically, we're talking about the critter that up in the client program was anonymously instantiated here by calling this default constructor. He doesn't even have a name. He's just a critter, and that's the way it is. But that critter is a critter. It counts as a critter. Even though he doesn't have a name, he's a critter. And he can call the move_to method. But the move_to method isn't typed out here. Well, because this critter class extends actor, anytime you see a method that doesn't have something in front of the dot, that means you're making use of a method that's in the actor class. So let's go to our quick reference and find the actor class. I'm going to go to the index at the back and find out what page actor is on. Now, that doesn't really help. So I'm just going to scroll right here. Now here's the API for actor. And here's that move_to method explained. Well, it's not really explained, but it does exist in the actor class. Let's find out where it's explained, or where the code appears. Move_to, I'm looking for the move_to method in the actor class. Well, I'm scrolling up. This is something you'll have to do in the AP exam sometimes to answer multiple choice questions or even write code on part 2 of the AP exam. I'm scrolling up. This is all given to you on the AP exam. And I'm looking for the move_to method. Right here it is. Here's where it's explained oh, if you bump into another actor, then that actor is removed, if that ever happens. Usually things are cleaned out of locations before the move to executes. Okay, so there's the move to method, and looks like they never gave us the code that shows how that works. So it's sort of black box, like the engine of your car. You just assume it works when you turn it on and push the pedal down to go forward. And that's that. The move to method was in the actor class, and we don't see its implementation. All we can see is the API that explains what it does. That, folks, is a complete overview of how this blue critter right here acts. Now let's click the step button to see it all happen. Okay, he ate the flower, or I should say processed the flower, and then his random move was to go down. I'm going to run the program a second time and see this time where this blue critter does a move to. Okay, he randomly moved up. While we're at it, let's see how this critter moves. Step. Now notice that critter did not eat that crab critter. Interesting. He didn't process him. Well, we saw a second ago in the process actors method that critters do not eat rocks or other critters. But what about crab critters? Well, because crab critter extends critter, a crab critter does count as a critter. Now, you cannot say that a critter counts as a crab critter. This extends relationship is a one-directional, one-way street. And we'll study later in this course when we more formally study something called inheritance. That, well, that's kind of a picky thing about things extending other things. But in this case, critters don't eat crab critters or other classes that are offshoots or children of the crab critter class. While we're stuck here in this video, let's just take a quick look at the crab critter class. You'll see that it has a default constructor that makes all crab critters red. I didn't notice up here. Look, critter doesn't have a default constructor. So it makes use of the actor class's default constructor, which apparently makes critters blue. But crab critters, it overrides that behavior and it makes them red. Other things to note here in the crab critter class. It has the method called getActors. Well, so did critter, but apparently this one works differently. It only, when it calls getActors, right before it processes them, it only gets the actors that are directly ahead of it. North, northwest, and northeast, or also known as ahead, half left, and half right. And those actors that happen to be, unfortunately, right in front of the crab critter, well, I'll show you. When a crab critter processes, actors, well, there's no process method in the crab critter class. So apparently, because crab critter extends critter, when crab critter processes actors, it uses the critter class process actors. And because this is not hardwired for all 8 surrounding positions of a critter, it only processes the critters that were stored in this array list of actors. So by doing this kind of thing, we kind of kill 2 critters with one method. This method, process actors, works for both crab critter and critter. But unfortunately, getActors up here did not work for both. So whoever wrote the crab critter class, the act of typing it out in this class supersedes, and what we say is overrides, the getActors method up here. And this one is ignored. It's not all the neighbors that are adjacent, but rather it's only the ones we saw a second ago that are directly in front of. They use an array here, but for these direction constants or these location constants, and it just works the way it works. You don't really have to trace that code too much. And so that's one difference between a crab critter and a plain critter. Hey, what else is different? Get move locations. Since it's found in both classes, this one must work differently. And here's where we see that a crab critter always moves only to its left or its right. Watch that guy in the red, the crab critter. Step, step, step. What a boring life. He only moves sideways. These plain critters go all over the place randomly, but a crab critter has boring movement, I guess you could say. There's nothing else interesting there in that get move locations method. Hey, let's look at the make move method. That apparently is different. You only override a method if you need it to be different when you make a class. Don't reinvent the wheel and type things out if they're the same. If some new function of an iPhone 6 is still the same as the way it worked in iPhone 5, then why retype that code? We just use the code that we've already written, and we do this stuff called extending through inheritance. Anyway, make move. What's the difference between a plain critters make move and crab critters? Oh, crab critter, he doesn't just move to the new location. He changes his angle with randomly. He flips a coin, and if it's less than 0.5, which means like say it's heads, he uses location.left here as this integer value. Otherwise it's right. That's I think -90, and I think this is +90 if you look it up. And then he sets his direction to whatever he's currently facing plus either 90 or plus -90. So in other words, he either turns right or turns left. Else, he calls his parent class's MakeMove method. When you see the word super, that just means go to the parent class and execute its version of the method that you have here after the dot. So there are situations where a crab critter executes this version of MakeMove, and apparently there are other situations where it does this fancy stuff. Let's watch the runtime once again. Now see this crab critter? If I click step, right now he's not changing his direction, but let's put rocks around him and watch him squirm a little bit. So now he has rocks, and he has a blue critter below him. He's like penned in there like in prison. And now you see how he turns. So he's turned 90 degrees to the right, and now he can break out. Let's be mean and put a rock there. Oh, now he's stuck. And but he can move sideways, so he does move normally until he's totally pinned in, and now you're going to see him turn 90 degrees. Each time he gets a chance to act, he turns 90 degrees. All of that is the way it is because of this overridden make move method. Is there anything else that's different between these two guys? Get locations in directions. So there's a method that we have in crab critter that we don't have up in critter. Apparently this method gets used somewhere in here. I'm not going to go over that right now, but apparently it's just needed because of what's happening up here. Okay, that is a full review of critter and crab critter, which are both fair game on the AP exam. There was one other important critter called a chameleon critter, which if you go to the quick reference, chameleon critters have two methods that are overridden. I don't know if they have the code here typed out or not. Yep, they do. Here's the chameleon critter class. You should be able to just look at this code and know how a chameleon critter is different from a plain critter. Let's do that real quickly. Process actors. So instead of eating things around it, I don't see any remove self from grid here. A chameleon changes his own color to be the same as his neighbors. He picks a random neighbor that's around him and then gets that random neighbor and stores that neighbor into a variable called other. And whatever other's color is passed as a parameter to the actor class's setColor method. Interesting. So Chameleon Critter extends Critter, which extends actor, and we're making use of all that power by calling methods that just do something interesting for chameleons. They don't eat things, but they do change their color to match the surrounding environment. And what does MakeMove do? It looks like we are making a move and pointing to the new direction that we're moving, kind of like bugs do in the bug class. Remember, a plain critter does not point in a certain direction. So this method was needed to make chameleon critters just be a little more interesting in that sort of way than a plain critter. Please, please, please watch this video and review this code to be sure that you understand how to trace critter code. It's a little more tricky than bug code, but it's very likely to show up on the AP exam in a large way.